So in y1, you have x squared. And in y2, you're going to put in negative x squared. And remember, you want to make this line thicker so that you know the negative one is the thicker one. What's happening to the graph? It's getting reflected. In which axis? In the x-axis. Now, how does that happen? Well, what you're doing is, before, when I gave you this yesterday, y equals x squared plus 3, you added 3 to the y. We agree? Today, I'm saying negative x squared. Is that negative with the x? If it's with the x, it would be in brackets, correct? Is it in the brackets? No, so it's not with the x. Anything that's in this bracket affects the x variable. Anything that's in front of it or behind it affects the y's. Anything that's in front of it, we multiply. So we're actually multiplying all of our y's by negative 1. So on your original graph, we have this. If we just multiply our y's by negative 1, this one's going to stay the same because our y is 0, right? But all of these are going to reflect down. The x's are going to stay the same, and all my y's are going to reflect down. And that's how you get a reflection, because all your y's, if they're positive, are going to be becoming negative, and if you have negative y's, they're going to become positive. So what I want you to do for this one right here is I want you to type this into your calculator and draw the graph down here. So just type that into your calculator and draw the graph of f of x down here. It's x squared minus 4x plus 4. Oops. So if we press graph, we can see it, right? Do you know how to accurately get the minimum? Do you remember? And this is a minimum, not a maximum, right? Because it's the lowest you go. So, I don't know if they'll let me write. You know it's a minimum because if a dude was walking down, those are his arms. I don't even know. I can't draw. I teach art on the weekends. No, I don't. Okay. So, he's walking down here. Can't even draw stick men, guys. This is bad. Can he go any lower? Can this dude go lower? Unless he's a shovel, he isn't going any lower. So what is this? The minimum he could go. And then this way, unless he has a friend and he could stand on someone's back, he's at the what? The maximum he can go. So what is this? Minimum. So we do second, trace. Which one? Three. And it says left bound. So we're trying to find the minimum. We're trying to find this. So we need to be on the left of it. We are. Hit enter. Well, I am. I don't know where you are. And then it says right bound. So now I need to be on the right of it somewhere of what I'm finding. Enter. And then guess just means, I don't know why it makes you press enter to guess it. So people will tell me, oh, it's at 2 and 2.8. Does this look like 2 and then up 2.8? No, 2.8 would be way up here. Is it up there? No. Look behind it. It says e to the negative 12. That's the same as saying 0.00011 zeros to 8. So what can you round that to? 0.11 zeros to 8. It's 0. So if you see an e to the negative 12 or e to the negative 10 or e to the negative 7, that's just 0, guys. Okay? Just a really long amount of zeros. So it's 0. So we know our minimum's at 2 and 0. So I'm going to go back to my graph. I'm going to go to 2 and 0. Okay, now I want points on both sides of it. So I'm going to go second graph. And it gives me the table of values that we used to make you find in grade 10 all the time. So I'm going to go and find 2, 0, which is right here. And I'm going to pick points on the up from it, and I'm going to pick points down from it. And then I have points on all sides of it, and boom, I have a graph. Okay? So here's 2, 0. I'm going to pick 1, 1, 0, 4, negative 1, 9. 1, 1, 0, 4, negative 1, 9. I've ran out of room, so I can't do that, right? Now I need to pick points on the other side. 3, 1, 4, 4, 5, 9. So 3, 1, and 4, 4 will fit. So I'm going to take them. 3, 1, 4, 4. And I have my graph, right? Calculator helped it. And I'm going to label it f of x. Y equals f of x, because that's what this one is. Now they want us to write the equation that represents negative f of x. Okay, so I'm going to write that down here. Y equals negative f of x. What is f of x? I gave it to you. What is f of x? Look right above it. X squared minus 4x plus 4 is f of x. We agree? So I'm going to take this f of x and I'm going to replace it. Y equals negative. I'm going to replace it with this. X squared minus 4x plus 4. And then I need to distribute. So I'm going to get negative x squared plus 4x minus 4. We'll type that equation in a second. But they want me to sketch the new one on the grid. If I have the original graph, I can sketch the new one really easily. I don't need to type that into my calculator. I know that the equation was y equals negative f of x. Is this with my x? No. And if it's in front, I multiply my y by it. So I multiply by y by negative 1. Next, like the week when you come back, we're going to have things like this. We're going to multiply our y's by negative 2 then, because we're going to have a reflection and a stretch. But whatever's in front of this f of x, we always just multiply our y by it. That's it, always. So I want to move a graph. If I want to move a graph, I'm going to use mapping. So my original points are these blue ones. They're x, y. They're going to become, did anything happen to my x? Nope, so it stays x. And what's going to happen to my y? Multiply by negative 1. So I'm going to apply that to all my points. So I'll start here from the left. 0 and 4. 0, 4 is going to become 0, negative 4. Then I have 1, 1. 1, 1 is going to become 1 and negative 1. 2, 0 is going to become 2 and negative 0, which is just 0. Wait, that's the same. So remember I told you we should connect them as we go along? Why is this one the same as this one? Because y is 0, and if I multiply y by anything, it's going to stay 0. Also, were you ever a kid? Everyone else thinks I'm crazy. I swear no one did that. I thought everyone did this. Sometimes it's just me. Were you ever a kid who walked up to a mirror with an object and stuck a mirror against the object against the mirror to see? No. Hmm? Yeah, and you're basically like in Narnia at that point with the object. Yes, thank you. Okay, I have one person. Have you ever, when you were a kid, taken an object and stuck it against like the bathroom mirror? That's it. And now your object is basically in Narnia, behind the mirror. No? It totally works. I believe it. Okay. Shh. Narnia. Okay. If you've never done it, you can imagine this. We agree? What's the only part that reflects in that mirror or goes into Narnia? Let's pretend I have a toothbrush, because that's probably what you would use. None of you did, because you guys are rule-following children. I stuck my toothbrush against the mirror. Well, it makes the mirror dirty, and then your parents to clean it. It's mean and vicious, but I guess I was mean and vicious as a child. So I stuck my toothbrush against the mirror. What part reflects in the mirror? Everything but what? The end of the toothbrush. The piece that's actually against the mirror doesn't reflect, does it? So this is reflecting in the what axis? What axis am I reflecting in? The x-axis. So this, I'm reflecting in the x-axis. Maybe none of you guys did this because you live in a city, but I lived in a farm that was at least 30 minutes from anything. So I had to have fun, so I stuck my toothbrush against the mirror. Okay, reflecting in the x-axis is like the mirror. And like the red part here is like Narnia, I guess we could say. So if I put the parabola against the mirror, the only part that's not going to reflect or change is the piece on the mirror. We agree? And now the rest of the red is in Narnia. This is good. Okay, so x-axis. What's the equation of the x-axis? Oh, we're bringing back last. Close. Opposite of x. Yeah. So our x-axis is actually a y value, correct? What are all the y values on this x-axis? 0. So they're actually the line y equals 0. Because I have 0 and what, neg 1, 2, 3, 4, 5, 6, 7, 8. I don't know. I just lost count. 1, 2, 3, 4, 5, 6, 7, 8. So negative 8, 0, negative 7, 0, negative 6, 0, negative 5, 0, negative 4, 0. The only thing that's 0 is y. So if they say reflecting in the x-axis, or they could say reflecting in the line y equals 0. They could change out these two things. They mean the exact same thing. So if they say reflecting in the x-axis or reflecting in the line y equals 0, that's just a fancy way of saying the x-axis. Why do they do that? Because they're testing if you know that the line is y equals 0. That's it. Okay? So the rest of my points are going to reflect down. So which point stayed the same? What's the only point that stayed the same? 2, 0, the one that was on the mirror, right? On the reflecting line. Points that stay the same are called invariant points. Points that do not change. So if you have only one thing happening, only one reflection happening, wherever that reflecting mirror is where you're going to find all the invariant points. So if we reflect on the y-axis, where do you think you're going to find all the invariant points? On the y-axis, because it's just going to be the point where you would stick the toothbrush up against, and it would reflect that way, but anything on here is going to stay the same. Okay, we're also going to later reflect on the line y equals x, which is actually that line that's 0, 0, 1, 1. This way, 0, 0, 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, negative 2. If I ask you where the invariant points are when we reflect in the line y equals x, you're going to tell me any point that's on that line. Right? So if we only have one reflection place, x-axis, y-axis, or that identity line, that's where all the invariant points are going to be. Sorry. So the invariant point of this one is 2, 0. And how does the graph of y equals negative f of x compare to the graph of y equals f of x? It's just a reflection in the x-axis. That's the terminology. So I told you have to write vertical translation by vertical translation 3 up, horizontal translation 2 right. You have to say reflection in the x-axis. If you just say reflection x-axis, not good enough. Okay? If you just say reflection, but no axis, it could be anywhere. I could reflect anything, right? Which is not what we want. Okay. Here's a graph given to you. They want you, so this is the original. The original is y equals f of x. They want you to sketch y equals negative f of x. Hey, I'm moving points. If I'm moving points, what am I going to use, Rachel? Is the answer of yesterday. Just repeat it. Mapping, yes. Okay. So if I ever ask you, just say that. That's where I'm going. Okay. So if we have a graph, we have a whole bunch of coordinates. We're moving coordinates. If we're moving coordinates, we use mapping. What's the only thing that changed here between this equation and this equation here? This little -1 in front. Is it with the x? No, so I multiply the y by it. So my points, my mapping is going to be x, y. It's going to become x negative y. And then I can just plug points in, get new point, draw new point, get new graph, done. Life is good. So I'm going to pick a point on each arm and the vertex. So let's pick, this one looks like it goes through it. So it's going to be at -3 and 1. So my original point is -3 and 1. It's going to become -3 and -1. So I'm going to redraw it. Does it look like it's reflecting in the x-axis? Yes, that's good, right? We want it to. Okay, then I'm going to pick a vertex. So -1 and 1, 2, 3, 4. -1 and 4 is going to become -1 and -4. And then I connect them, because remember that's what I told you we needed to do always? Would this be easy to just redraw the graph reflecting in the x-axis in this case? Yes. Do I want you to practice mapping so when I give you a whole bunch of like 6 different transformations, you can do it easily? Yes. So we're practicing mapping the whole time. And then I'm going to pick this one. Let's say it's at 1, 0. It's going to be at 1, 0. Wait a second. Stayed the same. Why did it stay the same? What is this reflecting on? What does that -1 do? We reflect in the what? In the x-axis or in the line? Y equals 0. So anything on here is invariant. So I have 2 invariant points. Make sense? What do you think we're going to do next? We just reflected in the x. What do you think we're going to do? Reflect in the y. Where do you think the negative is going to be in order to reflect in the y? The negative was in front now, and with the y, where do you think the negative is going to be in order to reflect in the y? With the x. Because in order to reflect in the y-axis, let's think about it. If I want to have a point here to be over here, what am I negating? What am I multiplying by -1? What am I moving? My x values, correct? My y's are staying the exact same height, but my x's are being reflected. So, reflections in the y-axis. So we want to regraph that graph we had. The same graph. I think that's the same graph. Is it the same graph? Should be. 2, 0. Sorry, go back for a second. I didn't label this one. This red graph should be labeled y equals -f of x. You need to label your graphs. It should be labeled y equals f of x. Wow, that's a really bad. This is supposed to be here. Oh. All right. So now, okay, we're going back to grade 10. People do not remember grade 10. So say I gave you f of x equaled 3x minus 1 in grade 10. We agree? And your teacher told you, now find f of 2. What did you do? Yeah. 2 in for the x, yep. So 2 is in what spot? The x spot. So that just means substitute 2 in for all the x's. We agree? So we go 3 times 2 minus 1, and we get 5. And we'd actually have a coordinate now at 2 and 5. That's what we found when we did this. We found coordinates in grade 10. You didn't really know that, but that's what you were doing. Okay. Now instead of f of 2, say I tell you f of negative x. That's the original equation here. So you guys told me 2 was in the spot of x, so I replace all the x's with 2. We agree? Now what's in the spot of x? Negative x. So what am I going to do? Replace all the x's with negative x. I'm going to go 3. Now I'm going to get negative x minus 1. So I'm going to get negative 3x minus 1. What you don't know is I actually just made this graph reflect in the y-axis because I replaced all my x's with negative x. So they want us to write the equation for f of negative x. So what do? We go to f of x, and we replace every single one of these x's with negative x. So we're going to get f of negative x equals negative x squared minus 4 times negative x plus 4. So basically every x gets put in brackets and replaced with negative x. Negative x squared is just what? X squared. Because it's a negative 1. Negative 1 squared is negative 1 times negative 1, which is positive 1. So I get x squared. Negative 4 times negative x. What's negative 4 times negative x? Negative times a negative is a positive 4x plus 4. So if I type that into my calculator, I'm actually going to get a reflection in the y. So type it into your y2. What does it reflect in? Y-axis. What's invariant? What point stayed the same? The point that was on the y-axis, right? The mirror. Remember the mirror as a kid? You didn't do it, but remember Mrs. Lepp having a mirror as a kid? If you press something against it, that part stays the same, reflects the rest, right? Okay. So now my mapping, because I'm going to move that graph without actually just redrawing it from my calculator, because the moment they put an F in my equation, I can't redraw it, right? I can't go to my calculator and type it in. So I need to be able to do all this stuff by hand. So my original point is XY. What's my new point going to be? What changed now between this equation and this equation? The x is negative. It's with the x. So if anything is in the bracket with the x, it affects my x value of my mapping. If anything's not in that bracket with the x, it affects my y values. So on the outside in front of the f or at the very back. Make sense? So if it's in that bracket, it affects my x. So I'm going to get negative x comma y. So I can plug in all my points to get my new point. I'm going to do them in red. So I have 0 and 4. going to become negative 0, so 0 and 4. Oh wait, that's my invariant point. It didn't change. Then I have 1, 1. It's going to become negative 1, 1. Look at it, it's reflecting. This is good. Oh wow, I'm just going to connect. So didn't need to do that. Invariant. I'll do it in a different color. Okay, then I pick the next one. 2, 0. It's going to become negative 2, 0. Then 3, 1. It's going to become negative 3, 1. And then 4, 4 is going to become negative 4, 4. Turn green. So the invariant point is at 0, 4. How does the graph of y equals negative f of x compare to the graph of f of x? It's a reflection in the what? Y. So remember, when it's with the x, it's actually a reflection in the y. It reflects in the opposite axis, which makes sense. Because if I'm taking my x's and I'm negating them, they're going to be over here, they're now going to be over here. Or if they're over here, they're now going to be over here. Which axis am I reflecting over? The y. If my y's are negated, I have a y up here, it goes down here. If I have a y down here, it comes up here. What axis am I reflecting in? The x. When you go to watch this, you're going to be like, great, I can't see anything you're doing. This is awesome. But you were here, so you got it. Okay, so this is a reflection. It's with the x, so it's a reflection in the y-axis. So I know I have y equals f of x, becomes y equals f of negative x. I'm moving a graph, so I'm going to use mapping. xy is going to become negative x, y. So I'll use that one again, negative 3, 1. It's going to become 3, 1. And then I'm going to use negative 1, 4. It's going to become 1, 4. And then I connect them right away. And then say I use 1, 0. It's going to become negative 1, 0. And this is my invariant point. Let me choose different color. And what I would like to see is you label this y equals f negative x. Label your equation. The moment you have 2, you should label your equations always. But the moment you have 2, you have to label them because you don't know which one's which. So once again, I'm reflecting on the y-axis and only the y-axis to where my invariant points on the y-axis. If I reflect on the x-axis and the only thing I'm doing is reflecting on the x-axis, where's my invariant points? The x-axis. So I could give you this as a diploma question. And I say to you, determine the number of invariant points. When and I'm going to label this y equals f of x. So when y equals negative f of x. The only thing I'm doing is reflecting in the what? I have a negative in front. What am I reflecting in? It is making the y's negative, so I'm reflecting in the opposite always, x-axis. So I draw my little x-axis. How many times they cross through? 1, 2, 3. So then I would get the answer 3. And they might say, put this in the numerical response box 1, in the first numeric response box. And then I could say, when y equals f of negative x. What's this a reflection in? It's making all the x's negative. So if it's making the x's negative, it's a reflection in the opposite, which is y. So I draw my little y-axis. How many times did it cross? 1. My answer is 31. Didn't have to do anything with this question. As long as I know that when it reflects on just one axis, where it reflects on that mirror where you're putting my toothbrush against is not changing. We agree? All right. So we're going to look here. I'm going to draw all the points for negative f of x in green. What am I so my xy is becoming what? Which one's being negated, the x or the y? The y, because unless it's in the bracket with the x, it does not affect the x. So I'm getting a negative y. X negative y. I have pencil, crayons, and markers if you want different colors. I'll put them on the table. Okay. So this is a reflection in the x-axis because it's always in the opposite axis. So it better be reflected in that horizontal axis. So I'm going to take the point 1, 2, 3, 4, 5, 6, negative 6, and 0. And it's going to become negative 6 and 0. It's staying the same. Why the heck would it stay the same? It's an invariant point. When you're on the axis that you're reflecting on, it does not change. So actually, this is going to stay the same too. And most people only say these two stay the same because they're the only bolded ones that are there. But what else stays the same? The other x-intercept. So these are all three going to stay the same. So I can go right away and just dot them. 1, 2, 3, 4, negative 4, and 1, 2, 3, 4, 5, 6. Negative 4 and 6 is going to become negative 4 and negative 6. And this is going to go here. This one is going to reflect up here. And I'm going to come back down. And it reflects perfectly in the x-axis. If that's overwhelming to you, please use mapping. So I have negative 1 and 6. It's going to become negative 1 and negative 6. Then I would get this point. Then I have 1, 2, 3, 4, and negative 3. It's going to become 4 and 3. You guys show me B. B is a reflection in the what? It's with the x, so it's a reflection in the y-axis, and it makes all what negative? X. Anything in that bracket with the x affects the x. Go. Try it out. So this point's going to stay the same. And then we have negative 6, 0 is going to become 6, 0. And then 1, 2, 3, 4. -4 and -6 is going to become 4 and -6. Connect. And then -1 and -6 is going to become 1 and 6. Connect. This can go here. Nope. Wow, why am I drawing these down here? Painful. Oh yeah. This is going to be here. This is a 6. That. It's really complicated when you have more than one graph on a graph because you start looking at the other points. Okay? Last little thing we want to go through is this. If I have a reflection in the y-axis, where does my negative go with? The words are always the opposite. The x. So I'm going to get -x. If I have a reflection in the x-axis, remember we need to understand, not memorize. Memorizing makes us mix it up, right? Think about it. If it's reflecting in the y-axis, I'm doing this. What's changing? My y's are staying the same and my x's are being made negative, right? They're changing. So I'm going to put negative with the x. If I have a reflection in the x-axis, so I have a reflection here. If I have a point up here, it's going to be down here. My x's are staying the same, but my y's are being changed. So it's going to be y equals -√x. That's why it's always in the opposite axis. Don't just memorize it, understand. If you guys are the memorizing types don't do well in 30-1. You need to understand why. The reason why is if I tweak the question a little bit, or you're like, in the x-axis is with the y, and the y-axis is with the x, and then you get flustered or anxious, then all that falls out of your brain. We don't want flustered and anxious stuff falling out of our brain. We want to understand why, so that when we're flustered and anxious, which was me on every single exam, I remember why it is, so I know why it is, so when I'm flustered and anxious, nothing falls out of my head because I know why, I understand it. So when it reflects in the x-axis, if it's down here, it's up here, what stayed the same? My x's, but my y's were negated. In order to make my y's negated, it can't be with the x, okay? And then this one, reflection in the y, I have it here. If it's here, it's going to be here. My y values are staying the same because it's the same height, but my x's are being negated. The only way I can do that is if I put a -1 in front of my x, because that makes all my x's negative, right? Understanding, I promise you, it will help you so much more than just memorizing, okay? Especially when we add more. All we have left is stretches to add to this, let me tell you. But once we put all three together, that's when people's brains just like drop it all off. It's like, nope, I maxed out. I can't do this. So we're going to learn it before the test and know it before the test, because what happens is people will mess up after if we don't. This is your little bit of homework, because this assignment is reflections and stretches, and if we ever taught them together, it would be like utter chaos. So it's a little teeny tiny assignment that needs to be done for Monday when you come back, okay? If you just went home and like just did this and didn't attempt to try and do this Sunday before Monday comes back, when you don't remember anything, you have to rewatch the podcast and waste time in your life, just go home, finish it, and then breathe for a week, because this is a really early break when you don't have to be like, oh, diplomas and stress. Just be like, take it off. Just take off your week. Finish your homework, take your week off. That's my suggestion to you. I get to student, you get to have a week off. You guys are better off than me. So finish your homework in all your classes and then take a break. Enjoy it.